Good day, learners. Today we are going to discuss range, a measure of variability in Basic Statistics Lesson 7. But before anything else, do not forget to like, share, subscribe, and hit the notification bell so that you will be notified for my upcoming videos.
Three, two, one, zero.
Uno, dos, tres, cuatro.
This video lesson will discuss about range, a measure of variability. Variability. Variability means spread, scattered, or dispersion. Variability occurs when subjects of the study in a set of observation vary with each other. There are two kinds of measure of variability. The first is absolute variability, which are the range, quartile deviation, average deviation or mean deviation, variance, standard deviation, and the second kind of variability is what we call relative variability, which are the coefficient of variation, coefficient of quartile deviation, and coefficient of mean deviation. Suppose the researcher wishes to determine the variability of two groups of senior high school students in a certain school with the same mean on their 140 item test, but the other group is more spread than the others. These are the data of the group A and the group B. The above two groups of senior high school students in a certain school have the same mean of 94 on their 140 item test, but group B is more scattered than group A. Because the scores of group A is homogeneous with the range of 30 and the scores of group B is heterogeneous with range of 70. As figure 1 shows, two groups of high school students in a certain school on their 140 item test having the same mean of 94 but different dispersion. Let us define range. Range is the easiest and simplest measure of variability because it can easily and readily understood. Range are classified into absolute range, total range, and the Keller range. Absolute range is the difference between the highest score and the lowest score. It is commonly used by the researchers because it is simply obtained by getting difference between the highest and the lowest score. For example, in group A having the data, for instance, in the figure 1 data, the highest score of group A is 110 and the lowest score is 80. Thus, absolute range is equal to 30. By computation, absolute range is equal to highest score minus lowest score. Substituting the value of the highest score, which is 110, subtracted by the lowest score, which is 80, that is why our absolute range is 30. Total range is obtained by getting the difference between the highest and the lowest score plus 1. Suppose we have now the data for group B. For instance, in the figure 1 data, the highest score of group B is 130 and the lowest score is 60. Thus, the total range is 71. Why? Using the formula, total range is equal to the quantity of the highest score minus the lowest score plus 1. Substituting now the value for the highest score and the lowest score, we have the quantity of 130 minus 60 plus 1. Simplifying 130 minus 60, that gives us 70. That is why we have 70 plus 1, that is equal to 71. Then we can say that the total range is 71. The next is the Keller range. Keller range is obtained by getting the difference between the 90th percentile and the 10th percentile. Suppose we have now the data. It shows in the table that the lowest score marked as 1, second lowest score marked as 2, and so on up to the highest score. First is we have to identify the data that falls within the 90th percentile by computing 90 times n divided by 100. So our n is 12 because there are 12 data. So that is why we have 90 times 12 divided by 100 is equal to 10.8. Then we have to round up 10.8. That gives us 11th place. So let us now identify now the 11th place in the table. And this is now the 11th place. And the data that falls within the 90th percentile is 99. Then we can say the 90th percentile is equal to 99. And the next step is we have to identify the score that falls within the 10th percentile by computing 10 times n divided by 100. Then our n here is 12. We have 10 times 12 divided by 100 is equal to 1.2. Then we have to round up 1.2, that is equal to 2, or the second place. So from the table, this is now the second place. Then we can say, and the score that falls within the 10th percentile is 85. Then we can say that 10th percentile is 85. So after getting now that 90th percentile and the 10th percentile, we can now substitute now to our Keller range, which is the 90th percentile minus the 10th percentile. So substituting the value for the 90th percentile, which is 99, and the 10th percentile, which is 85. Then we can say the Keller range is equal to 84.
And that ends our video discussion at this moment. Thank you for watching. But before you will end this video, please do assess your learnings by answering the self-test activity. Thank you.